Hi, so in this video I want to talk about the Faker library. So this library can be quite useful when we're testing code or when we need to generate synthetic data sets, right? So often our code involves working with data and we want to test our code using that data, maybe as we're developing or maybe as we're writing things like unit tests. However, sometimes the data that we have available is real data that may contain actual confidential or even sensitive information like PII information. Now, we still want to be able to test our code. So there's a couple of issues, right? One is we may not even have access to real data because it's PII, and therefore that access to that data is restricted. Secondly, even if we do have access to it and we're writing automated testing, we do not want to put that data into a GitHub repo, for example. That's a bad idea. So instead, what we need to do is we need to build up these synthetic data sets, this fake data that mimics the real data that our program is going to work with, but it's completely synthetic. So there's no worries about PII or things like that. And this is where the Faker library can come in. So to install Faker, you just do a pip install Faker. And if you look at the project repo, which is linked below, I have that also in a pipenv file if you use pipenv. So in this notebook, we're going to take a quick look at the library and some of the functionality it offers in order for us to build synthetic data sets. So the first thing is Faker library uses a random number generator to generate sequences of choices. And we can set the seed so that we get repeatable results. And this may be one approach that you might take when you're writing unit tests. You want to be able to write unit tests with the same data every time. So one way would be to set the seed. Typically, though, what I tend to do more is I will generate this data and these data sets using Faker, and then I'll include the data set, the synthetic data set, into the GitHub repo. That way I know the data doesn't change no matter, this seed issue. So let's jump in and let's actually start using it. So the first thing is I'm going to import the Faker class from the Faker module. Then we're going to set a seed. Now you do not have to set a seed, right? I'm just doing that so we get repeatable results. And I'll discuss a little bit later in the video. There's actually a bug currently in the library with the seed, but I will talk about that later. So now we're going to create an instance of the Faker class, like so. And then this Faker class has a variety of methods that we can use. Now, in general, the methods in Faker are generators. So this is what we're going to do here. So I'm going to loop 10 times. So for that, in range, and then we'll do 10, so that we're doing this loop 10 times. I use the underscore to indicate that I don't care about the actual loop variable. And then I'm going to call that function 10 times, like so. And so when we do that, you can see that it outputs these names. Now, if we reset the seed, we'll get the same sequence of names. If I do this without reseeding, I get a different sequence. But if I reseed first, like so, then you can see that we end up with the same list of data. So that's what the seed is used for. And you can find documentations for all the various categories of synthetic data. They're called providers, and they're located here. And it's linked in the Jupyter notebook right here. So you can see that you have these different providers like address, automotive, bank, barcode, credit card, companies with company names, jobs, miscellaneous, phone numbers, persons. That's the one we actually used. If you look at the person, you have these functions. Now, the providers, the functions that are available, the methods that are available in the providers are available directly under the Faker instance, class instance. You don't have to go ahead and do faker.providers.person.name. So if we take a look, we'll find that there is a document for name, like here, right? We just call the name and it's going to return a string every time. So in this person provider, you'll notice that we have a lot of other things. We have things like first name as list, first name female, if we want female names. Then we have first name male. Then we have first name or language name, for example, which is just going to generate languages. language names. Last name if we just want the last name. And there's things for prefix and prefix for females or males and so on. So there's a lot of functionality just in that single provider. And then you have a bunch of other providers, and we'll take a look at a couple of those in this video. So let's try some of those out. So again, I'm going to reset the seed. You don't have to do that. And then I'm going to create a faker object, which is going to be an instance of the faker class. And then I'm going to repeat something 10 times. And I'm going to print a few things. So let's focus, for example, on the female prefix first name, and then we'll do last name. So we're going to generate now a full name with prefix, but using the gender that we have available in that library. So prefix, female, and of course this is a function call, and then we'll do faker first name, female, and then we'll do faker.last name. There's no gender identity for last name. So if we do that, you can see that the prefixes are like Mrs., Miss, Doctor, since doctor can apply to either male or female, and so on. So that's what those generators are. So we also have a ton of other providers. As you saw here, for example, we have an address provider. And if we look, there's different functions, again, methods available in here. We have address for a full address, the building number, the city suffix, if you want a lot of cities and with, let's say, Furt, like Frankfurt or Chester, and so on, Haven, New Haven, so on. So let's go ahead and generate some addresses. So again, we could reset the seed. I'm just going to forego that. And then for range in 10, again, we'll just do 10 of them. And let's go ahead and print a full address. And then what I'll do to differentiate the addresses, since they are going to be over multiple lines, is I'll print that as well. And let's fix that. So as you can see, I have these addresses. Now you'll notice that these addresses, at least for me, since my particular locale is US English, are US-based addresses. And I'll talk about locales in a bit more detail later on, so that you may want to have data that doesn't deal with just US-centric kind of data. Let's go ahead and break things down a little bit. Let's say for underscore in range, and again, we'll just do it 10 times. And then I'm going to print, and I'm going to use faker building number. So I'll use that particular synthetic data, building number. Then I'm going to want faker dot, let's do street name. And then we'll do the city. Then we'll do the postal code. And then finally, we'll do the country, like so. So again, basically I'm going to build up the components of an address, but using the various components instead of getting a full address back. This may not be what we want in our data, right? We may have columns in our data sets where we want the street name, the city, the country to be in separate columns. This over here isn't going to help you for that. This approach will. And let's fix that to number. And there you go. So we have the building number, then we have the street name, then we have the city, then we have the postal code, and then we have the country. So as you can see, in this case, some of this data is not limited to US versions like the countries. Now the language is still English, right? But I do have more countries than just USA. So you've got to be a little bit careful when you work with this kind of generation of synthetic data, because having, a Wilson Parks Road in Johnson's Mouth in Poland is probably not realistic. So let's look at locales now, because some of the synthetic data that Faker generates can be tied to specific locales. And to do this, we need to let Faker know which locale or locales, plural, we want to use. Now also note that not all providers support all locales. It's a work in progress. And you can certainly contribute to the library if you want to add a locale for a particular provider or provide a new provider altogether. Now there is a link that I have in the notebook under locale, and that will help you determine what's actually available, what's localizable basically in the different parts, in the different providers. And we can go to this link over here. And you can see the localized providers. You have the locale and then the providers that are available under that particular locale. Okay, so this will give you an idea of what's available. So for example, if we look at, let's say, HIIN for Hindi. So HI, let's go look at that one, since that's the one that I mentioned in the notebook. So you can see that we have localization for this particular locale for address, date, time, person, and phone number. So let's go ahead and try it out. So here, let me reset my seed. Again, you don't have to do that. But if you do, you should get the same sequence as me, as long as you're using the same version of the library. So that's one important point, is that as you've changed the version of this faker library, the same seed may not generate the same sequence. Hence why I was saying right in the beginning that my approach typically is to generate the synthetic data sets and then save them off to a file and then use that so that I have consistent repeatable data and consistent repeatable tests. So here we're just going to set the locale, and we do it this way. When we create the faker class, we pass in an array with the locale. And this should already give you a hint that we can actually pass multiple locales in. But let's just work with one for the moment. So now if I do, if I go ahead and print some things out, we saw what we had. For example, addresses were supported under this locale. So at least if you look back to here, for this locale, address is supported, right? As well as person, phone number, and date time. And again, I'm just going to print some lines in between just so we can differentiate the addresses, like so. And as you can see now, we have a very different look to our addresses. I can't read this script, so I don't know if this is correct or not. I will let you be the judge of that if you can read this. And if we look at the person provider, so we can say for that in range 10, for example, and then we can print faker the full name, right? The name, like so. And again, we get these names. Now, according to the library's documentation, we can specify multiple locales. That's what I was saying, right? When we create the class, it's a list of locales. And then the sequences of values, as long as they're supported by the locale, are going to be randomly selected from each locale as a whole. Unfortunately, there's a bug in the current version of the library, and this isn't working correctly. There is a link to the issue that I put in the Jupyter notebook. So we're going to have to do a workaround here so that we can actually generate, let's say, names from multiple locales at the same time. You could certainly generate a bunch of names from one locale, another bunch of names from another locale, and so on, and then merge them together. That also works. Another way that we can do that is by using Python's built-in random module and the choice and choices function that we have there. So let's go ahead and create an object that has multiple locales. So faker, let's go ahead and we need to pass in an array, a list. So NUS, we'll take English, US English, we'll take France, French, and then we'll do Spanish, Spanish, like so. So this is an object that has multiple locales. And let me go ahead and say for range, let's repeat 10 times, and let's print fake.name, like so. And you can see that we have an issue over here. This data just repeats all the time. And I was able to narrow down that if you actually reset the seed to something that is not a specific value, that fixes the problem. So as you can see here now, we have a bunch of different names. We have some English names. We have what looks like a French name over here, and this probably looks like a Spanish name over here. If we want to have further differentiation, we could add in also another locale. Let's do HIIN. So that will be even more evident that we have this mix going on. But as soon as you do this, or any value for that matter, right? I could do 10. You can see that there's a bug in the library. So let's work our way around this problem because I want to have repeatable data. If you don't, then it's perfectly fine to do this, and then you can just use the functions, the way they were intended to be used. But let's say that you absolutely need to set a seed for some reason. So let's go ahead and create a list of locales. So I'm going to separate this out so that I have my list of locales in a list. And let's do es_es. And then let's do the Hindi one as well, like so. And then I'm going to create a list of providers. And those providers basically are going to be a faker object with a single locale, right? And so we can do it this way: faker locale for locale in locales. And this is because this issue that we're seeing here does not happen if you have a single value here. So if we go ahead and just create a single value, you can see that this is working properly, right? Well, let's actually set the seed to something specific. You can see this is working properly. We've seen that before. Now you can also just pass the string in as opposed to that. That works fine as well. Okay, so what we're doing here is we're creating multiple faker objects with a single locale in each. And that's just to work our way around this bug. So now what we're going to do, from random, I'm going to import choice and choices. We'll use both. And then I'm going to create a provider function, which I'm just going to use a lambda here. You can just use also a regular function. And basically, it's going to arbitrarily choose one of the providers. So this is the way I'm randomizing which provider I'm using, because each provider has its own specific locale. So I'm going to use this function, basically, to pick a provider randomly from providers. So the provider function will give us that random provider, and now we can use it to get the next value. So now what I'm going to do, I'm going to reseed now faker to 0, you'll see. And then I'm also going to set the random seed to 0, because this will give me then consistency in how I'm choosing the providers randomly. So if we do that, then I can go ahead and say for that in range, and let's do 20 this time. And let's go ahead and print provider. So now that's a function call, which returns a faker provider and name. Actually a faker object, but instantiated for a specific locale. Oh, I didn't import seed, so let's do it this way. Sorry. Okay, and now you can see that now I have names that are coming from the different providers. And if I rerun this, I should get the same result again and again. Okay. Now we can modify this slightly to give us the ability to weigh the choices of locale providers. And that's also something that the faker library is supposed to support, but as I said, there's a bug right now. So instead, to mimic that, we can use the choices function that we have in random. So let's go ahead and do this. Let's just do 2 locales this time. And let's do this one, and let's do English US, like so. And then I'm going to create some weights. I want to weigh, let's say, the data that I'm generating with 1 for the Hindi locale and 2 for the English US. So I want more English US data being generated than Hindi. Okay. So with that, I can now go ahead and say providers is equal to, so this is the same as before. We're just going to create a provider, basically a faker object for locale in locales, just like before. But our provider function now is going to be a little bit different. What I'm going to do is I'm going to use the choices function from Python. We're going to pass in the providers, and we're now going to pass in the weights. Now, with the choices, it's going to return multiple choices every time it chooses something, and we can specify how many we want. So I just want 1. I just want to make a single choice every time. And I'm going to therefore, and this always comes back as a list, so I'm just going to take the first element of that list. Okay, so now let's go ahead and set our faker seed 0. We can also set our random seed to 0. And let's say for that in range, let's say 10, and let's print provider.name, like so. And as you can see now, we get a list of both, names from both locales, but you can see there's a lot more data on the English US side than the other locale, and that's because of the weight. If we were to change the weight, let's say 2 and 1, like so, then you can see that this is different. Now we have more from that locale than we have from the other one. Okay, so that's just to work our way around that particular bug. Now another thing too, and it's often in our data that we want to produce unique values for a particular field in our data set. So far, the functions we've used do not guarantee that the same value, be they name, address, or any of the other provider functions, will not be returned more than once. And if you generate a large data set, there's a good chance that you will be generating the same data more than once for a particular field. In many cases, that's fine, that's not an issue. In some cases, however, you want to guarantee that a particular sequence of values will only contain unique values. And Faker gives us an easy way to do this. So for example, if we take a look, if we go back to the providers over here, and we go to this one here, Social Security number. These are numbers in the United States that are basically identifiers, unique identifiers for people. And so it will generate those numbers. Now, by default, if we were just to call it, at some point, we may get a repetition in this number. And Social Security numbers are supposed to be unique. And so as we're generating the synthetic data, we want to ensure that. And we can do it this way. So let's go ahead. I'm going to reseed Faker. Then I'm going to create another Faker instance for my providers. Then I'm going to say for that in range 10. And we're going to print. So this is very much the same as before, faker.ssn. So if we do that, we're not guaranteed uniqueness. Now I'd have to probably generate quite a few in order to hit a duplicate. But if I want to guarantee that this is going to be unique, then all I need to do is put in .unique.ssn. And Faker will maintain basically a list of what it's generated so far and make sure that it only outputs unique values. Now, of course, this does use more resources because Faker now has to basically maintain the state of what it's generated at this point, as opposed to just generating one item and then just letting go of whatever object it was using. It's now going to have to keep that history. But it does give you the ability to create these unique Social Security numbers. And you can do that with any of the providers. Now, it may be that the number of values you are building will exceed the available possibilities for a particular provider generator. I'll show you an example of that. When that happens, Faker is going to raise a uniqueness exception. So let's go ahead and actually import that exception. So from faker.exceptions, let's import the uniqueness exception. And if we look at, let's say, the countries. So if we go back to address, and remember we had that country like over here, right? So it's going to generate a name of countries randomly. But we know that there's a limited amount of countries in the world. We don't have, an arbitrary number of countries. They're limited. There's a finite number. So let's go ahead and cause this exception to happen by requesting unique values and requesting a number of values that's going to exceed the number of countries that Faker is able to provide. So let's put a try catch, and then we'll say for that in range, and that's actually 244. Faker has 243 unique countries. So here what I'm going to do, I'm not going to print them out, but I am going to call the country generator, but using unique. And then I'm going to catch the exception here. So accept uniqueness exception. And then we'll just print and we'll say not enough unique values available. Yeah, I can type. So if we run that, you see that it actually did raise the exception. Now, if we change this to 243, there are 243 countries in Faker. You can see we don't actually get an exception. And in this case, if you want, we could print it out as well. So there you go, right? You have all these countries. But if you try and make a unique generator, essentially, and you don't have enough base data to fulfill that uniqueness, then you will get an issue. Now, if you want to check that those are indeed unique, that's pretty straightforward to do. Let's go through that exercise quickly. So I'm going to make a list, basically, saying faker.unique.country for underscore in range 243. Okay? And then all I'm going to do now is I'm just going to test that the length of the countries list is equal to the length of the set of the countries. So basically, I'm going to transform countries into a set, which eliminates any duplicates. And then I'm going to check that the length of the deduplicated countries is the same as the length of the original thing. And that gives us true. So that shows you that it was indeed unique. All right, so in terms of other providers, there are many providers available. Just see the documentation. Let me just paste in an example from the notebook, just so you can see some of the ones. So we saw SSN before. We have color name, for example. We can generate ISBN numbers, the different types of ISBN numbers. We can generate emails, let's say a company email. We can generate in the banking industry this IBAN number. Even, for example, if we go and look at the providers, you have this user agent, right? That's what you get in various browsers. And you can actually generate these fake user agent strings as well, if you want to. So let's go ahead and just run this. And you can see we have a social security number, we've got a color name, we've got an ISBN 10 number, a company email, we've got a bank IBAN number, and we've got a user agent string over here. So these just come from a variety of the different providers. So take a look at the documentation, see what's available there. Now there is one interesting provider, and it's called the Python provider. It is this one over here. And it has different functions. You can take a look at those. But the one that I want to look at is the ones that we can use to generate Python objects like lists and dictionaries. Sometimes we may want to generate synthetic lists and dictionaries. So let's take a look how we would do something like this. So faker seed, again, I'm going to set the seed, and I'm going to create an instance of the faker class. And then for that in range 10, again, I'm only going to do 10 examples, 10 iterations. And I'm going to use the faker.pylist. And it is basically over here. Pylist is over here. So it's able to generate lists. And we can actually specify the value types that we want to be in that list. So it's just a handy way of generating that. We, of course, don't have to use faker for that. We could use just random number generators and things like that from the random library. But here, it's actually pretty straightforward. So what I'm going to say is that the number, and this is the name of their argument. So the number of elements, I want that to be equal to 6. So I'm going to generate lists of 6 elements, right? So this is not the number of lists that I'm generating. This is the number of elements inside each list. I'm going to be generating this list 10 times. Each one will have 6 elements. Then we can define whether do we want the number of elements in the list to be variable or not. In other words, if you're thinking about it as a two-dimensional array, do you want a ragged array or do you want a non-ragged array? Do you want everything aligned? So you can control that by using this variable number of elements. And in this case, I do not want a variable number of elements. I always want 6. Okay, so we set that. And then we can specify the value types that it's going to pick from. And again, it's going to be a random selection of that particular type. And you usually pass them in as strings because there are other things that we can pass in here than just the base, Python types. So we can do this. And if we generate that, and I guess I should print the data so we can actually see it. So we have these lists, right? And you can see that basically every list has 6 elements, and the elements are either Booleans or integers. Now you have other value type choices as well. And the thing is, you can pass in one of the faker types, so the faker generated names in there. So let's change the value types here to name. Remember that we had this name that we could do. And then we also have, if we look at the, I don't know if it's under user agent. No, it's under internet. If we look at internet, we should have a host name. Okay, so this method over here in the internet provider produces a host name with a specified number of subdomain levels, which defaults to 1. So I'm going to use that. I'm going to go in and say I want a host name in here. So again, I'm going to be generating these lists with 6 elements, but the types now are going to be either name or host name. And you can see that's exactly what we get. We get a host name over here, or we get an actual person name over here. So that's pretty interesting, and you can work with PyDictionary as well. I'm just showing you some basics, and so the PyList is that way, and then the arguments that you have for dictionaries are very similar. Of course, now you got to worry about generating keys and values, and you got to specify things for that. But another one that's pretty interesting, I thought, was the PyString format. So if we go back to Python over here and we search for PyString format, it is this one over here. And the documentation isn't great, and this is why I wanted to show you that in the video, but this allows you to generate strings that conform to a certain format where you can decide where you want characters and where you want integers, or digits to be more specific. Integer isn't quite right, it's a random digit between 0 and 9 inclusive. So let's do that. So here, let me again reset the seed, and I'm going to create another faker object. I can reuse the same one. I don't have to do this all the time. Now I'm going to set up a template. And my template is I want to generate a string that is going to start with x dash. So that's always going to be there. Secondly, I want 2 characters right here. So for the character, we use the question mark. The question mark is a placeholder for a single character, and the pound sign or the hash sign is a placeholder for a digit. So I'm going to say I want 2 digits after that, then I want a dash, then I want 3 digits, and then I want a dash, and then I want a character. So this is what my template is going to look like, and I'm going to generate strings based on that template. I'm going to say for that in range 10, and we're going to print faker.pystring format, and then we'll pass it the template that we want to use. And so as you can see now, the data that I've generated matches that particular template. So again, very useful when we're generating synthetic data. For example, you may be generating account numbers, and you know that the account numbers that you're dealing with are going to conform to a specific format. And you can do it very easily using this template over here. Now, you'll notice that all the characters were basically random. I've got a mix of uppercase, lowercase, and they're all from A to Z, lowercase and uppercase. We can actually restrict what the set of characters are. And we can do that by essentially specifying that in this. So let me go ahead and copy paste this. And then here, so I'm going to do PyString format template, and then I'm going to pass it another string. And I'm going to say I want it to come from these characters. So it's going to basically look at every character in the string, and those will be the only characters it will use in the template's placeholders for characters. So if we could do that, you can see now it's using those. If we had used, let's say, A, B, C, D, E, F, and we run this, then you can see we're using A, B, C, D, E, F, and so on. Now, the PyString format function is actually using another function called bothify, And that one is documented here. So I've got the link in the notebook. Let's scroll to it and click on it. So it's here. And you have these default providers. You have these base providers, basically. And you'll see that there's a bunch of them. Like, for example, Hexify. It generates a string where each circumflex in the text is replaced with a random hexadecimal character. Well, we could do that using that template, right? Because we could say that we want to limit the characters to A, B, C, D, E, F, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can include that as strings and then just use placeholders for the strings. But essentially, you'd be able to achieve the same thing. Now we have also this bothify. I don't know how you pronounce it. It generates a string with each placeholder in text replaced according to the following rules. Number signs that, question marks that. So you'll notice that's kind of exactly what we did, right? We specified the template and we specified the letters that we want to restrict to. So you might be thinking like, well, why do we have PyString and bothify at the same time? Let's take a look at how bothify works. And I'm just going to basically paste this in like so. So basically it's the same code. We've got the same template. Let's actually use the same character strings over here and let's see what we get. And in fact, you can see that we get the same sequence. Well, that's also because we set the seed. So why use this one as opposed to bothify? Well, the thing is with PyString format, it's actually more versatile because in your template, you're not restricted to using these characters. You can also specify provider function names like name or email or host name. You can actually use that in the template. Let's go ahead and try that. So again, I'm going to reset my seed. I'm going to create a faker object. And then my template is going to be this. I'm going to say it's customer. So this, of course, doesn't change. This is going to be a constant. Then I'm going to use these double curly braces and specify that I want to use the faker name provider here. And then I'm going to put a space and then I'm going to put parentheses. So these again is a constant, right? But in the parentheses, I'm going to use the email provider or the email function in one of the providers. And now I can go ahead and say in range 10 and we can say print faker.pystring. PyString is one word format. And we're going to give it the template. And you can see that we get this data generated. We have the name that was generated, and then we have the email. And of course, you can also localize this, right? So as you can see, there's a lot of different options available. There's a lot of different providers. Now, if the built-in providers are not sufficient, there are also community-built providers available. For example, you can pip install something called Faker Air Travel. And again, I've got that documented in the notebook. So if we go back here, you'll see that I talk about this Faker Air Travel. Now, I've already included it in the pip file. So all you need to do is just pip install it or pip install from the pip file. And then you just import it. And there is a provider in there called Air Travel Provider. Let's take a look and see if we can find documentation on Faker Air Travel. So I'm just going to do a Google search for it. And there we go. There's Faker Air Travel. We can go to the home page. And you can see it goes to the GitHub repo. And this has a little bit of information about it. And you can see that you can create airport objects. And then you have airport codes, you have airlines, you can generate flight numbers and that kind of stuff. Let's just try it very quickly. So from Faker Air Travel, I'm going to import Air Travel Provider. And then again, I'm going to use faker.seed0. Now, I'm going to create the Faker object. But what we need to do now is we need to inform Faker about this external provider. We need to register this provider. That's very easy to do. We say Faker add provider, and then we specify the particular provider that we want to use. Okay, so this is how we would use a third-party Faker provider We import it and then we tell Faker about it by using the add provider function on the Faker instance. And now we can use it just like any other provider. We can say faker.airport object, for example. We can call that and we will get an airport object. We can take a look at a flight number. We can generate a flight number, for example, or a flight information, not just the flight number, but you can see that the airline, the origin, IATA, the city, state, etc. Okay, and then for the destination as well. So that's the way that they're generating a flight record. So there is a lot more to the Faker library. Feel free to explore it. It is fairly powerful. Documentation can be sketchy at times. As you saw, when we looked at the documentation, it wasn't always very complete or very explanatory. So certainly you can go and take a look at it from the GitHub repo perspective. You can dig into the code if you need to really find out more details, like how is the barcode being precisely generated, let's say in the English US locale. And you can take a look at the code. A lot of the code is in the init.py file, I should say. So you can take a look and you can dig in and you might get a little bit more information about what's going on. But that's the Faker library. Very, very useful. Now, one thing I want to mention is that while I was creating this blog post and producing this video, I ran across another synthetic data library, which I hadn't seen before. It's called Mimesis. I don't know if that's how you pronounce it, but it looks pretty advanced as well. Looks like there's a lot of different functionality as well. So I'm planning on actually looking at this library, and I'll create a video about it once I've learned it and figured out what's going on. So I'll get back to you and let you know how good it is and how it differs from Faker. All right, thanks for watching.